Hi, my name is Kelly Schild. I'm the Territory Sales Manager for TV Pipe Supply. Thanks for having an interest in watching our pipe rehab and more video today. Today I'll cover an overview of TV pipe. I'll talk about SnapTite, the product and the installation details, summary. I'll also briefly mention profile wall pipe. I'll discuss CentriPipe, a centrifugally cast concrete pipe, and also HydraTite, which is a mechanical joint repair option for separated pipe joints. Treasure Valley Pipe, as it was originally called, was founded in 1957. TV Pipe now is the largest reseller of corrugated metal pipe and corrugated HDPE in Idaho and eastern Washington. We originally owned Interflow Pipe System that directly competed with ISCO and SnapTite, and then SnapTite acquired Interflow in October of 2019, and as a result of that, TV Pipe is now a distributor of SnapTite's line of products in 8 states, including Oregon, Washington, Idaho, Nevada, Wyoming, Montana, Utah, and Colorado. The SnapTite liners range in diameter from 8-inch to 63-inch outside diameter. We also have a threaded liner pipe for smaller access places like manholes that ranges in 3-inch to 22-inch. And then for treatment of larger diameter pipes, we have the option of profile wall HDPE for that ranges up to 144 inches in outside diameter. You're probably familiar with slip lining, but if not, it's simply placing a new pipe in an old pipe. It's a no-dig trenchless solution. In a nutshell, we excavate a small area to work, and to slide the new pipe sections in to the old pipe, we have to have a place to line them up and snap them together and get them in the old pipe. Then we will clean and remove any debris from the host pipe. We'll install any necessary slide rails to help slide the pipe in, and any blocking and grout and vent tubes. We'll insert the new pipe into the existing pipe, create bulkheads at the inlet and the outlet to seal the ends and to prepare them for grouting of the annular space. Then we will grout that annular space and fill all voids, and then cap and conceal any grout and vent tubes, and then restore the area, and we're done. This pipe is a typical candidate for either replacement or reline depending upon its physical location, which I'll talk about in the next slide here. But this has lost its structural capacity. It's got a rusted out invert, it's losing its soil envelope, and this could be causing, if there's a roadway above, it could be causing issues with that roadway and could be creating sinkholes and things like that that can be a hazard. We often see the areas of pain as rusted out pipe inverts and separated pipe joints, and if left long enough, these can eventually cause sinkholes in roads or deflections in the road surface. We can look for opportunities to use reline during paving projects. If there are any culverts running under the area that are in bad shape, that would be a good time to treat them so that they're not causing issues with your new pavement down the road. Road widening projects are a good time to be looking at culverts. They may, if they're in bad shape, they may need relined, and if you're relining them in an area where you are widening the road, the SnapTite can also be direct buried, so it can be used as an extension solution also. When we're looking at repairs versus new construction, we want to consider deep fill areas for reline, as those may be expensive to dig up. We want to consider reline in areas where there are underground utilities that we maybe don't want to dig around, or in areas of highly traveled roads or areas of lengthy detours that could be costly to the public if they were shut down. This is kind of a typical situation. where reline would be a better option. SnapTite is a solid wall, high density polyethylene with a snap together mechanical joint. These are some pipes that have been completed. You can see in the left side there's the circular typical pipe, and then in the bottom right we have an oval version, so that's another option we have. This is an illustration of what the pipe looks like and the joints. On the left end there you can see the SnapTite female joint, or the outline of it, and the male end on the right. Those two snap together. In the illustration on the bottom right, you'll notice there's a gasket in one of those recessed areas of the joint, and when those two joints snap together, they squeeze down on that gasket, creating a watertight joint. As stated earlier, SnapTite ranges in outside diameters from 8 to 63 inch, and then we have profile wall that can go up to 144 inch OD. The SnapTite has a design life of 100 years as designated by the Plastic Pipe Institute. It's highly corrosion resistant and impervious to acid rain, road salts, fuels, and motor oils. And it has also demonstrated abrasion rates up to 10 times that of steel. It also has your the UV stabilizers, and so it's virtually unaffected by the sun and the weather. SnapTite meets AASHTO standard M326. Our country's infrastructure has been facing critical problems, and that led AASHTO to create this standard. It's the only culvert lining standard in the US, and 50 out of 50 states had to approve the spec before it became official. It states joints shall not reduce the inside or outside diameter of the liner by more than 1/4 inch. And all joints shall meet watertight joint requirements as set by ASTM D3212 and using a gasket meeting ASTM F477. The SnapTite solution can restore the culvert to better than new condition. During the process, the soil envelope is restored during the grouting process. It is suitable, as mentioned earlier, for direct bury application and can be good for road widening culvert extensions. It has a low Manning's coefficient, which can in many cases increase hydraulic capacity, and also no water bypass is necessary if installed during lower flow. Speaking of possibly increasing flow rates when lining with SnapTite, this is a table prepared by SnapTite. It assumes low slope conditions of 0.1% slope, CMP Mannings of 0.24. This shows different culvert sizes and the resulting flow rates when lined with SnapTite. And that is assuming the conditions I just mentioned. I've expanded the view of the 36-inch culvert. You'll notice there are 3 situations there, being lined with 28-inch SnapTite, 30-inch, and 32-inch. When lined with 28-inch SnapTite, the expected flow can be 112% of original capacity. If we go to a 30, it's 135%, and if we go up to a 32 liner, we could expect 160% under these 0.1% slope conditions with the CMP Mannings of 0.24. And this assumes that the culvert is not in inlet control conditions. If the inlet is limiting flow, we have the option of adding a HydraBell. When we have plain end head walls under inlet control conditions, as pressure increases, we can have 15 to 20% flow rate improvements in low head conditions to 35 to 40% in high head conditions with the HydraBell. So it's an option in certain situations that can improve your flow. These are a couple of photos of the HydraBell. It's also a snap-on system. We can also oval pipe by compressing it and inserting a structure to temporarily hold it into place This is what it looks like installed into the pipe. And once we grout the annular space and that's allowed to set up, then we can pull out that temporary structure and the oval pipe will maintain its shape. And we're left with a permanent oval shape like we see here. And so for lining of, let's say, box culverts or squash pipes, we can maintain more of that cross-sectional flow area by fitting the shape of the host better. I also just wanted to make quick mention at this point that we can install fish passages if you have any projects like that. The advantages of SnapTite, it can be installed with a handful of people and minimal equipment. If you have crews that can self-install, you can install it on your own schedule and you don't have to work around contractor schedules. So that can be very beneficial to counties and highway districts to keep their crews busy during slow times. They can go line culverts. This pipe can be pushed or pulled through existing culverts with ease. It's flexible and ductile, which is a very forgiving feature if the culvert isn't perfectly straight. It can flex and get around some defects that maybe some other pipes that are really rigid can't. It's also very impact resistant and doesn't break or crack during installation, and especially during cold weather, that can be a problem with some other types of pipe systems. Just to go along with that, no special care in handling is needed. You do want to not beat up those joint ends, but the pipe itself is very tough. The start of installation, we want to excavate an area like this if necessary. That just allows a place for the sections of pipe to be lined up and slid into the host pipe easily. Then we will clean out the culvert, removing any debris. And then at that point we can place strips on the bottom. You can see on the top left they've placed wooden strips in the bottom to slide that culvert or the liner pipe in. Sometimes they grease those to just allow it to slide more easily. You can also see blocking on the top of the pipe. In this situation, they've placed that up there to inhibit any flotation of the pipe during the grouting process. If that's a concern, there are other methods that can be used, such as drilling some holes in the top of the pipe and running a jack from the floor of the pipe up to the ceiling of the hose pipe to temporarily hold it. Some contractors will sandbag the ends and fill the pipe with some water to hold it down. You can also see the PVC grout tubes that have been placed in the hose pipe, and that's for pumping in the grout and also for air vent tubes. We recommend cutting a nose cone simply because that can avoid the pipe from hanging up when pushing it through. These ends can be cut with a chainsaw, and the pipe tends to curve in once these ends are cut like that. But if it's not enough, the contractor can drill holes in the end, or the crew that's installing it can drill holes in the end and pull those tips together to allow that pipe to slide more easily. Next, we would slide in the first section of pipe. In this case, they've used a loop system to pull it in. They can also be pushed in with a backhoe bucket or a track hoe bucket, and you just want to make sure, if that's the case, that the end of the pipe is protected. Here's just another situation where the pipe is being pushed in. In that case, it's a little different. They've actually installed the grout tubes to the liner pipe instead of to the hose pipe. After the first section goes in and the second section is brought in place, we will put a gasket on that section on the male end and then slide that into place, snap it together. This is often done with a come along and chain method, like we see in this photo here. Then we position the next section, place a gasket on that, and slide it together and snap it. And we just repeat that same process until the hose pipe is lined. At that point, we want to seal up the ends of the inlet end and the outlet end with a bulkhead so that we can grout that annular space. This is one that's being hand installed. We typically put them in 12 to 18, or actually 12 to 24 inches deep, depending on the pressure from the grout that is anticipated. There's the next step and completion here. This is what it looks like when it's finished. The photo on the right, they've just trimmed off the grout tubes and filled them in so you can't see them. The grouting process is probably the very most important aspect of a relining project, and in the early days the thought was bring a truck in, pump in the concrete, what could go wrong, right? Well, they ended up getting pipe collapse and joint leakage, and they found that contractors and specifiers just lacked a thorough understanding of the grouting process, and when grouting was left up entirely to the contractor, they found that that's when problems usually did occur. It was during grouting, and because of the lack of the understanding of this process, ISCO developed a grouting program in the mid-1990s. The grout viscosity needs to be low enough to where it pumps through the grout tubes to fill the annular space. It also needs to be liquid enough to fill any erosion and void spaces of the soil envelope, as that's an important part of this system. If the grout is too thick, the viscosity is too high, this may not be achievable and we may not get a good result. Hydrostatic pressure is another thing to keep an eye on, and as a rule of thumb, ISCO recommends not exceeding 2 psi hydrostatic pressure on the liner pipe wall. This number assumes 120 degree Fahrenheit grout temperature, which is the average heat of hydration with foam generated cellular grouts. This number also has a factor of safety of 2 built in. We want to use caution when using higher density grouts. That can increase hydrostatic pressure against the pipe wall. It can create viscosities that may be too high to reach void spaces properly to restore the soil envelope and fill the annular space. It may also subject the pipe to flotation. Higher heats of hydration, if that occurs, can weaken the pipe wall strength, and that can also have an influence on that recommended wall pressure. Steep slopes can also increase hydrostatic pressure. This is a great table for reference. In the left-hand column of the table, you will find lift height, and that is the height of the grout as you pump it into the annular space. Across the top of the table, we see densities of grout ranging from 30 to 135, and that's density in pounds per cubic feet. Right above that, you'll see a gray bar, and that kind of breaks apart your different grouts, like cellular grouts are on the 30 to 90 range typically, and reduced density flowable fills are in that 95 to 115 range, and then flowable fills can be in that 115 to 135 range. All that data in the middle of the table is grout pressure in PSI based on density and depth. So let's look at the transition from the white color to the yellow. That's that 2 psi zone. That's the recommended max wall pressure that we use when grouting with SnapTite. As we approach that yellow to orange range, that is approaching 4 psi, and that's where our safety factor of 2 starts to run out. So as we enter the yellow zone and we approach the orange zone, we're at greater and greater chances of collapsing pipe. So let's take 40 pound per cubic foot grout as an example. We can achieve a lift height in that annular space of 7 to 8 feet where we're starting to reach that 2 psi zone. As we get nearer and nearer to 14 to 15 feet, we're increasing chances of collapse. Let's compare that to 100 pound per cubic foot grout. As we near the 2 to 3 foot lift height, we are approaching that 2 psi. As we approach 5 to 6, we are getting near to that collapse zone. So grout densities make a big difference. You'll notice on the bottom there, I have in blue, there's the unit weight of water. I'll talk about that next. We want to use the lowest density grouts possible. That's a recommendation, and if there is water present in the annular space, the density of water is 62.4 pounds per cubic foot. So in that case, we would want to use a grout with a higher density so that we could displace any water that may be present in that annular space. Otherwise, you want to use the lowest density possible. It's good to consider using multiple lifts, as you can install one lift, keep that pressure low, let it set up, and install another lift. You can limit pressure if you're using higher density grouts to avoid overpressurizing that pipe wall. I've put down here a YouTube link, and this is a video by Mike Whitehouse of ISCO, how grout selection impacts design and installation. And if you'd like to learn more about the grouting process, that's a good video to watch. I recommend that you do that. In summary, slip lining can be a better option than replacement in certain situations. HDPE's smoothness can increase flow in many cases. HDPE has a 100-year life expectancy. It's very durable, ductile, and corrosion resistant. During the grouting process, we fill that annular space and repair the soil envelope. And grouting is one of the most critical steps in rehabilitating a failing culvert. If you have any questions on SnapTite, just feel free to call me or shoot me an email. I'm happy to try to answer any questions you may have. So next, I wanted to briefly mention large diameter profile wall pipe. It's lightweight. It has multiple joint options such as bell and spigot. Threaded joints can also be welded. It's still got the good hydraulic efficiency and long service life. And we can have up to 144-inch diameter with profile wall. So we can line the larger pipes with these types of pipes. These are some of the different profile walls that you might see. The reason for profile wall for the large pipe is material usage. If we went with a solid wall pipe for really large pipes, there would just be too much material required to make that pipe, and it would be far too expensive. So these profile wall designs were made to reduce material consumption and to still meet the needs of the liner. I've just for fun compared 54-inch SnapTite solid wall, which is 120 pounds per foot. I've compared that to 84-inch profile wall. They're about the same weight, so the same material usage. So You can see that difference there. Just a couple photos of profile wall pipe. Project that's finished using profile wall. Again, if you have any questions, we have different types of profile wall available. If you have a project of any interest, don't hesitate to contact us. HydraTite is a joint seal system for separated joints in pipe. It's been around for several decades. It's a mechanical system that can be installed inside the pipe. It's cost effective. It's NSF 61 certified, and it's pretty fast to install. You only need a small crew for installation. There's minimal flow restriction. It's approved by many state DOTs. There's no welding required, and it has a 50-year design life. This is an illustration of the HydraTite joint system. You'll notice the black rubber gasket made of EPDM rubber has some grooved ends or ribbed ends. There's an expanding stainless steel band or ring that goes inside that. It expands against that rubber seal and presses those ribs into the host pipe, creating the seal. You can get these with a test valve if you would like to check for leakage. That's an option. The bands, the retaining bands come in 304 or 316 stainless steel. They come in one or multiple piece depending on your access requirements. They're flexible. They come in 3 different sizes. The smaller one spanning 5.75 inch gaps, the next being 9, and the next in size is 16. These can be added together to span larger gaps. HydraTite can treat pipes from 18 inch to actually, I believe it's now 26 feet in diameter. There's a good video here on HydraTite. It's about 7.5 minutes long, but I'm going to skip it, but I will include it and send it along with this recorded video. Again, if you have any questions, always feel free to contact me by email or call me. Happy to try to answer your questions. Last of all, I'd like to talk about CentriPipe. It is a centrifugally cast concrete pipe liner system, often referred to as CCCP. It's a cementitious fine aggregate material that is applied with a spin caster, as you can see in the picture there. That's a photo I took from one of my projects in Salt Lake City area called Bangor Interchange. You can see that spinning head in the middle flinging that material out and sticking it to the pipe wall. That material is spun out at a high rate of speed, high RPM, and that sled is pulled through the pipe to basically put a layer on that wall about a 1/2 inch thick per pass. So on that particular pipe, they'll do about 1 pass to fill corrugations and a couple more passes to achieve 1 inch liner thickness. So CentriPipe centrifugally cast material can treat about 36 inch to 120 inch diameters, and that's with the spin caster. We can do larger sizes if they're handgunned, and we can do any size actually handgunned and any shape. A person must be inside the pipe, and that's why that 36 inch limitation on the smaller end. The cost efficiency, however, is best over 5 foot in diameter. That's where we really become cost effective with this system. The design thickness of the liner can vary. A lot of them are around 1 inch unless they're pipes that have minimal overhead cover and heavy loading. This system is structural. It uses the host pipe only as a mold, and the new concrete cementitious pipe that is placed inside has the same expected life as new concrete pipe. A little bit of history about APM Permaform. They own CentriPipe. They started in 1975 with a system called Permaform that was basically a system that just placed a mold or a form in a manhole, and then they would pour a new manhole around that to rehab manholes. In 1985, they developed a bidirectional spin caster and started vertically spin casting manholes for restoration. It dramatically cut down the rehab time. Then in 2003, they introduced CCCP, or horizontal lining. And originally they thought the MS-10,000 material would work, but it didn't. They actually had to spend about 6 months redesigning material so that it would work in a horizontal application. This is your equipment. In the upper left, you see the bidirectional spin caster. That's the spinning head. It's run by an air compressor. And below that, you see the CentriPipe retrieval sled that mounts that head and holds it in the center of the pipe, and then it's pulled through by the cable winch assembly that you see. We also have the mortar mixer pump assembly where the bags of grout are mixed and prepared to pump. And we have usually a trailer with support equipment, but overall a pretty small footprint. We don't need a really large area to work in with this system. The bidirectional spin caster will conform to shapes easily. The upper left there is a vertical manhole, cylindrical. The upper right, you see it's a rectangular shaft. The bottom is a squash pipe. It will conform to any of these shapes. If we do a square or rectangular shape, you will get some slight rounding of the corners, but it will conform to those shapes very well and maintain that cross-sectional flow area in a culvert like a squash pipe, if that's of importance to you. The material is one of the most important aspects of this type of a system. Our CentriPipe PL8000 material is a densely graded quartz sands with special Portland cement. It's got modified polymers, fumed silicas, quartz silicas, organic and mineral fibers, rust inhibitors, rheological modifiers, reactive pozzolans, just a lot of different materials that go into this mix. It reaches an 8,000 psi compressive strength in 24 hours, and in lab testing, not out in the field, it can reach 10,000 psi. If you think about this, what this material has to do, and I'll use the Bang Girder project in Utah as an example, we accessed a 400 plus foot length of pipe from one end. So this material has to be liquid enough to pump that distance and then leave that spinning head. But once it leaves that spinning head, it needs to thicken up enough to stick to the pipe wall and the ceiling of the pipe and stay in place until it has time to set. So this material is highly engineered and one of the most important aspects. And if you ever look into a system like this, make sure you research the company and their material, because there are a lot of new companies coming out with these types of systems, and just make sure that they've got a reliable material that's going to hold up if you're going to use one of them. This material also has mixed throughout the mix a system called Crystal X. It's a crystalline powder mixture, and what this does is when this crystalline admixture comes into contact with water, it forms crystals. Those crystals form and they seal up the pores in the cement and in any cracks. And although our mixture is designed to crack very little, all mixtures can crack a little bit in certain situations. And these are some cracks that have self-healed that are in the picture here. Those white areas that the arrows point to, those were areas that admixture formed crystals and sealed up those cracks. And so if you develop cracks up to the size of the edge of a quarter, this material will self-heal as long as it's exposed to water. This is a chart on abrasion resistance. I'm often asked how abrasive resistant is CentriPipe PL8000 material. So we had a test done with a control of 6,810 psi concrete compared with our CentriPipe PL8000. This is a chart of volume loss compared to abrasion cycles. The control is in the blue, the CentriPipe in the red. You can see that it does wear indeed better than the concrete. We're on quite a few QPLs in different states, the most important being California and New York, because those are the hardest to qualify in. We're in many other states and many others are pending. If you have a project that you're interested in evaluating CentriPipe, we will either have you fill out or we will fill out for you an engineering request. And that form asks a lot of different things like the size and the slope of your pipe, depth of corrugations, are there any bolts protruding, what's the depth of bury, minimum and maximum, is there groundwater present, are there roadways running over, what are the pavements running over, is it asphalt or concrete, what's the thickness of those pavements, what are the load requirements of the traffic running over that roadway. We'll evaluate all these factors, we'll get them down on this list, and then we will send this to CentriPipe and they will perform an engineering evaluation and give us an engineered liner thickness. And I pulled out a section of that report here. You'll notice that it shows the liner thickness among a bunch of other things. And we will provide that. And once we know that information, we know the liner thickness that's required for your specific situation, we can develop a ballpark cost estimate so that you can use that for comparison or budgeting purposes. The city of Chicago performed the world's largest manhole restoration project, and they used the CentriPipe manhole rehab system using our MS 10,000 material. This manhole collapse was after a 21-inch rainfall had happened, and they actually were able to pull up this manhole in one solid piece and reuse it. They were very happy with the way the structure held up. Florida DOT, we lined this 156-inch diameter CMP for them on State Route 66 or State Road 16, excuse me. You can see if you look at the photo, there's just very little distance between the top of that pipe and the roadway. So there's a lot of load transferred to that pipe. And they, about 5 years after post-installation, they installed strain gauges and ran this loaded semi back and forth across this pipe. The semi was 83,620 pounds. They found no significant strain, so they were very happy with the results, and this did show that the pipe did meet its structural requirements. Australia, Rio Tinto Mines, they had some culverts to reline. They hired independent firm Rockfield Technologies to evaluate a couple of systems. One was a reinforced concrete liner and the other was CentriPipe. This is a table of the recommended lining thickness. The different culverts are on your left. There's a 48, 124 inch, 120 inch, 156, 48, 108, and so on. You can see the concrete lining thickness also towards the center there. We've got a 6-inch one for the 48 inch on the top row. There's a 6-inch concrete liner, and then the comparable CentriPipe recommended liner thickness is 1 inch. If we go the next line down, the reinforced concrete was 11 inches. There was also one 14 inches. The CentriPipe recommended liner thickness for both of those was 2.25 inches. And this goes on down the line, dramatic difference in liner thickness. So the CentriPipe is a thin shell, very strong liner. So it's designed to minimize the loss of cross-sectional area. So if that's important, then it may be a good system for you to look at. Rockfield Technologies performed finite element analysis on this project, and they validated the results by field measurements. And they found that the CentriPipe theoretical method was conservative for both bending and compression factors of safety. This is that same Florida culvert prior to and post liner installation. The photo in the bottom right is about 6.5 years after initial installation. Just another project in Oregon, a 72-inch diameter CMP that was lined. This photo is 2 years after installation. Rectangular application here. Just wanted to show you one of those. If you go to the website, centripipe.com, you can find many case studies if you'd like to look at other projects and learn a little bit more. And otherwise, my presentation for today, again, feel free to call me or contact me with any questions that you may have, and I'm happy to try to answer them. And thank you for attending. I appreciate it.